So we have the problem where 2 kilograms of chlorine has been added to 50,000 liters of water. However, this is double the required amount of chlorine. You only need 1 kilogram. This sets up a differential equation problem where we need to find an expression for the concentration of chlorine and the change in concentration of chlorine with respect to time. This leads into our first problem, 6a, where we need to allow water to leave the pool, specifically at a rate of 50 liters per minute, while adding 50 liters of pure water to the pool so that the volume is constant. And in part B, we are asked whether or not by 8 a.m. tomorrow morning, where it is now 5:30 p.m., is there enough time to get the correct concentration of chlorine in the pool? So some important information to take out of the text is the mass of chlorine in the pool initially and what is required, and the change in mass per minute of the flow of chlorine water out of the pool and what is entering the pool, where dc dt is the mass of chlorine in and the flow out of the pool. So we are now set where we can create a differential equation by taking the flow of chlorine out of the pool and equate that to the negative of the mass of chlorine, dependent on the time of course, over the total volume, which will give you the concentration times the flow, thus giving you the change in mass of chlorine over time. With this change in mass of chlorine over time, we have the total volume, 50,000, and the flow, which was given to you by 50 liters per minute. We're leaving everything in liters. C is dependent on time, therefore we cannot substitute anything, and it is a variable. You now have the perfect setup for a differential equation where if you divide by C, you will have the integral of 1 over C dc equal to the integral of negative 1 over 1000 dt. Integrating there, you get the line ln C equals minus t over 1000 plus k. K is just the choice of constant since we already have C in the equation. It is now time to substitute the initial condition into the equation so as to find the constant k. Once substituted and values are plugged in, you get k equals ln 2. So ln, the absolute value of C, is equal to minus t over 1000 plus ln 2, which can be simplified by putting it all to the power of e. Notice that you have to put the entire line on either side of the equate sign. Then you will get C is equal to 2e to the minus t over 1000, since this e can be simplified as e to the minus t over 1000 plus e to the ln of 2, which is equal to 2 times e to the minus t over 1000. That is all part A. So now to find part B, all you have to do is substitute C equals 1 kilogram and find T. And there you go. You find that you have 14.5 hours until the required concentration must be reached, and the required concentration can be reached in less than that.